Hey guys, how's it going? So today I'm going to share my solution to the Pramp's uh, award budget cuts problem. So this problem I think is asked by Google. Um, so let's see. The award committee of your college asks you for assistance with a budget allocation problem they're facing. Originally, the committee planned to give an research grants this year. However, due to spending cutbacks, the budget was reduced to new budget dollars, and now they need to reallocate the grants. The committee made a decision that they'd like to impact as few grants recipients as possible by applying a maximum cap on all grants. Every grant initially planned to be higher than cap will now be exactly cap dollars. Grants less or equal to cap obviously won't be impacted. Given an grants array of the original grants and the reduced amount new budget, write a function find grants cap that finds the most efficient manner a cap such as the least number of recipients is impacted and the new budget constraint is met. The sum of n reallocated grants equal to new budget. Analyze the time and space complexity of your solution. So let's see this example. So our input is 250 to 120 and 1,000, and the new budget is 19, and the output is 47. Why it is 47? It says that given this cap, the new grants would be. Oh, let's copy it here as well. So here is the explanation. Given this cap, 47, the new grants rate would be this 2 followed by 47. Notice the sum of the new grants is indeed 190. So basically this question is asking us to find the new cap given the new budget so that the new array sum will be equal to the new budget, but it can impact as little number in the original array as possible. So obviously given this 47, the 2 will not be impacted. Every other 4 number will be impacted, and but the sum is 190. So this question is actually quite tricky. It's not as easy as you think, and my solution is I think it's not optimal. It's n square solution, but this is how it works. So first of all, I sort the array. So basically, this array after sorted will become like this. Why do I sort? Did I sort the array? It's because I want to loop through each number in the array and find if the number is a potential cap. So basically, at when I equal to 0, I find if 1,000 can be my cap. Obviously, 1,000 times 5 is 5,000 and it's exceeding new budget, so it's not gonna be my cap. So I increment my I. At this point, I calculate whether 120 can be my new cap. So if 120 will be my cap, then this number become 120. This is 120, and this is 150 and 2. And obviously, it's exceeding 190. The sum exceeds 190, so 120 cannot be my cap. and I increment it. And I test whether 100 can be a new cap. So this 3 number become 100, and this is 50 and 2, and the sum is more larger than 190, so it cannot be a cap. So I increment my I, and I test whether 50 can be my new cap. And all this number can be 50, so it sums up to 200, and this is 2. So 202 is larger than 190, so this cannot be my new cap. So I go to here and try to see if 2 can be my new cap. And it can, because 2 times 5 is 10. 10 is less than 190. So 2 can be my new cap. So now my array is like this. However, this cannot be my real array because the new budget, so the new array's sum should be the new budget. So I will keep the original 2, but change this 4 number. So 190 minus 2 is 188. So 188 divided by 4 is 47. And that's, so I'll put 47. So that's how it works. So basically, instead of like finding the cap, in the beginning, actually because our goal is to impact as little number in the original array as possible, we just sort the array and try to find which number is the threshold of the cutting point. So and we keep the rest of the smaller number the same, but then we count how many number we have larger than the cap and spread out the remainder to the rest of the number to be the cap. I'm not sure if my explanation makes sense, but basically you can see that I sort the array. I append 0 because there can be a situation that, for example, 2, 4, and 3. So let's see if our original array is 2, 4, and our new budget is 3. First, I sort it reversely. So so if my I is here, then 4, if like 4 is the cap, then the array will be will sum up as 6 and is larger than 3, so it cannot be the cap. And if I increment my I, and my I, if it's the cap is 2, then this number also becomes 2, and this array is 4, and 4 is still larger than 3. So, and I am at the end of my loop, so actually I can add a number 0 so that I can try to test whether the last element can be a cap or not. So it's a bit confusing, but let's see here. So I initialize my count at 0, and this count is like counting how many number we are currently at. So we write a for loop to go through each number in the original grants array. First of all, we increment our count, and this list comprehension is that we try to make a new array. So for test cap in grants array, test cap if x is greater than test cap, else x for x in grants array. Basically, we're saying that for each test, for each number in the array, it's a testing cap. So for example, if our I is at 120, So right now, our test cap, we are at 120. If for each number in the array, if the number is larger than 120, you will become 120. If it's less than 120, it will be original. And after we get the temp array, we sum it up. If the sum is smaller than the new budget, we find our threshold and we break. If the count is at the very end of the array, so remember we append 0, so if it's at the very end of the array, we know that even the last element in the array cannot satisfy the new budget. So basically we just divide the new budget by n. We do this is because somehow like the Pramp's Python is Python 2, so we have to add this somehow. If it's not, it means that at some point our index I is satisfied the cutoff point. So we get that index and we sum up what's the rest of the array. So for example, if our I is here and at this point, we know that 2 can satisfy, so we sum up what's after 2. It's 2, and we subtract it from the new budget. So this new budget is 190. Under cap sum is 2, so this is 188, and we divide by the number. So we divide 188 by 4 and we get 47. And also this part is because Pramp's Python is Python 2, I guess. So let's run it. Okay, it passed all the test cases. And the time complexity is actually O n squared because we're writing a for loop and then we have at least comprehension. And this is also O n, so it's n squared. And because of the sorting, it's n log n, but the n squared dominates, so the time complexity is n squared. But actually, Pramp's own solution can be n log n. So, but I haven't figured out what's the like algorithm behind it. It's hard for me to understand, so I'm not sure about this. Also, the space complexity is O(n) for my algorithm, but for their algorithm is O(1), so definitely take a look at their answer. But for their answer, I find it's very hard for me to understand. So I just want to share my solution here. Thanks for watching my video. If you like this video, please give me a thumbs up or consider subscribing.